Hello everyone. In this video, we are going to solve the problem number 1.13 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. So a point A moves uniformly with velocity v so that the vector v is continually aimed at point B, which in its turn moves rectilinearly and uniformly with velocity u. So let us say we are having point B and point B is moving in a straight line, that is the meaning of rectilinearly, with constant velocity of u, and A is moving with a constant velocity of v such that at the initial moment of the time v is perpendicular to u and the points are separated by a distance l, and it is asking how soon will the points converge. Okay, so let us say we are having point A here and point A is moving in this particular direction with velocity v, because it is saying that initially both velocities are perpendicular to each other. Okay, and as the B is moving in this direction, the A is continuously following B, and then finally both are reaching somewhere at this particular point. Okay, so let us analyze the motion of A and B. For example, let us say in a very small time duration B has moved by a certain distance, let us say very small distance. So and A has moved by a certain distance which is also very small, and then if we draw the line joining these 2 points, then this is the line and we know that it is aiming towards point B. So that means the A velocity is in this particular direction. Now after another time of very small, let us say delta t, let us say it has moved by this particular distance which is also very small, and then the A has reached in this particular direction at this point. Now again it will move in the direction of the line joining these 2 points. So let us say this is the line joining these 2 points, then this will be the direction of the velocity. Okay, and it is continuously moving. What is the meaning of that? Let me explain with an example. For example, let us say I am having some sort of radar, and then this radar has to, this is the rotatable, and some, let us say some object is moving in this particular direction, and then this radar has to detect this particular object. So in order to detect this particular object, let us say I know the velocity of this object. If I know the velocity of this particular object, then I'll find the distance between these two particles, the particles and the radar system, and then we will find the appropriate angular velocity of this particular radar, and then we will rotate accordingly so that this eye will always in the towards the direction of the object. But let us say if we don't know the velocity of the this particular object, then in that case we have to first measure what is the velocity of this object, then after some time we have to like rotate this particular radar system. So in that case there might be some sort of lag because of the measurement error. For example, we have measured what is the velocity of this particular object and then given the feedback here, and accordingly it has rotated. Till then the object has moved by certain distance. Let me tell this distance may be delta L, but this is some distance which will be there at what distance it has already moved. So in that case we cannot move this particular radar system continually, there will be some sort of lag, but here there is no lag, and that's why it is continuously moving in the direction of the velocity of the B. Okay, now let us assume that in some point, let us say at this particular point, at this particular point. This is the length, let us say L, capital L, and initially it was having the length of small l. Okay, and this is the direction of velocity, and in this direction this is the velocity of B, particle B. Okay, now if we assume that in this direction we are having the small distance of, let us say, ds, then if we want to know what is the rate of change of ds, and it is decreasing, that we know, so we can write minus ds upon dt is equal to velocity in that direction. What is the relative velocity of a in that direction? So if we take the component of velocity of b, and let us assume that this particular angle is theta, then this particular component is u cos theta. Then relative velocity of a with respect to b, we can write v minus u cos theta. Okay, so from here we can write minus of ds is equal to v minus u cos theta into dt integral. Okay, and we know that initial distance was small l, and later on they will converge to a single point. So at that point we will have the s is equal to 0. So we can write integration of ds from s is equal to l to s is equal to 0. So if we integrate this one, we will get l is equal to v minus u cos theta into dt integral. Okay, and here this particular angle theta, that is keep on changing from this particular point to when it is converging, because initially if we say that we are having the velocity in this particular direction, and then v is in this particular direction, so what is the angle between the v vector and u vector? It is 90 degree. So basically initially the theta angle was 90 degree, and later on when they are converging, the angle is 0 degree. Okay, so it is varying from 90 degree to 0 degree, and it is how it is related to the time that we don't know right now, but we know that what is the v and u, that is constant throughout the time. So we can write v times dt integral minus u times cos theta dt integral. This we can write, and let us say the total time to converge it is taking as capital T. So we can write the limit of integration t is equal to 0 to t is equal to capital T, and here also we can write t is equal to 0 to t is equal to capital T. So this we know, this is integration of dt is t, so we can write t minus u times cos theta into dt integral t is equal to 0 to t is equal to t. Now if we talk about the component of the velocity in the horizontal direction, then it was having the a has the velocity of how much? Let us say at this particular point, let us say, so it will have the velocity of u times, this is the angle theta, so we will have the velocity of v cos theta. And in the x direction, both particle A and particle B are moving by the same distance. So let us say, if we understand it carefully, so point B is starting from this particular point where x is equal to 0, let us say, and point A is moving continuously towards B, and here also x is equal to 0, and both has converged to this particular point where x for both A and B is same. Okay, what does that mean? The meaning of this is that both the distance traveled in x direction, x direction is same for both A and B. Okay, so what is the component of A in this direction that we have seen here? This is v cos theta, and the velocity in this direction for B is u. So the distance in the x direction we can write, for b let us say we can write u times dt integral from t is equal to 0 to capital T is equal to v times cos theta dt integral t is equal to 0 to t is equal to capital T. So this is the distance traveled by b and this is the distance traveled by a. This is nothing but velocity into dt. Okay, instantaneous velocity into dt. So this will get the distance. Okay, so if we solve this particular equation, we will get u times t is equal to v as it is cos theta into dt integral t is equal to 0 to t is equal to t. And from here we can find cos theta dt integral t is equal to 0 to t is equal to capital T. We can write u times capital T divided by v. Okay, so this is the expression we got, and if we substitute the value of cos theta dt integral in this particular equation, then we will get, if we write this one, we will get vt minus u times, what is cos theta dt integral? U capital T divided by v, that is equals to how much? That is equals to L. So from here if we solve this one, we will get v square minus u square times t divided by v is equal to L. From here we can get t is equal to vl divided by v square minus u square. So this is the total time traveled by both A and B when they will converge. I hope the entire procedure is clear. Thank you.